So again, I'd like you to pause the video now, read over the question and try and construct your own diagram so that you can see what's going on. Okay, so in this question, we're going to be applying Lemmy's theorem, which is just an application of the sign rule. So all it means is that if I have forces acting in three directions, then I call this one F1, then that force F1 over sine of this angle in here is going to be the same as the force of F2 over the sine of this angle here, which will be the same again as F3 over this angle in here. Okay, so we just have to really construct our diagram for this one. So, particle of a mass of 20 kilograms. So that means the mass in here is 20 kilograms, which means that it is acting with a force of 20 times gravity. Okay, so it's supported by two strings of length, 12 centimeters and 9 centimeters. The ends of the string are attached to two fixed points 15 centimeters apart. So let's start by constructing this, and they're on the same horizontal level, which is why I've started doing that dotted line. That's there, so that's 9 centimeters, and the space in between is 15 centimeters. Determine the tensions in the string by the sum of vectors. So we're going to be applying this formula with this information over here. First thing I need to do is I need to work out the angles in between. So to do that, I'm going to be using, I've got these three here, which means I'm trying to find an angle, which means I'm going to be using cosine rule. So cos -1 is equal to a squared minus b squared plus c squared all over -2 BC, and that will give me the angle that I'm looking for. Now, I've remembered this and I've rearranged it on my piece of paper, so if you can't remember this formula, make sure that you can rearrange it to get there. Okay, so I'm going to start plugging some values in to find out the angles. So I'm going to call this angle in here A. I'm going to call this one over here B. And I'm going to call this one in here C. Okay, so let's calculate A first. So A equals cos inverse 1. Now, if this is A, then that's my opposite side. That's going to be little a. 9 squared minus 12 squared plus 15 squared all over -2 times 12 times 15. And that's going to give me an angle of 37 degrees. Now, I'm not going to show you how to reconstruct all of them. So this little one in here, you'll get an angle of 53 degrees. And the last one, I can do 180 minus 37 minus 53, or I could apply the formula again, doesn't make any difference. And that's going to be 90 degrees. Now, the reason why I want to find all of these three angles is so that I can apply it on our diagram below. So if this angle at A at the top here was 37 degrees, then that means that the angle in here is also going to be 37 degrees. And if this angle here of B was going to be 53 degrees, and that means this angle in here is 53 degrees because they're acting as alternate angles on parallel lines. Okay, so I'm going to redraw the diagram just so I can clearly see what information I've got here. All right, so this one here, we'll call it force 1, is equal to 20 times G, which is 9.8. And the angle up here is 90 degrees. So the first one I'm going to start writing is 20G, or times 9.8, I just don't have a calculator handy, over sine of 90 degrees. Now that's going to be equal to, now this angle in here was 37 plus 90, because that's a little right angle in there. So 37 plus 90 makes 127 degrees. And this one over here, we'll call him force 2. So force 2 is the one that we're trying to find. and he's over sine of 127 degrees. Okay, the next one that we're finding over here, force 3, is going to be equal to sine of 53 plus 90 makes that 143 degrees. So 143 degrees. Okay, so now I can start putting some numbers in these things just to solve it. So I'm going to solve for F2 first, then I'm going to ignore this piece of information and solve for F3. Okay, so 20 times 9.8 divided by, now sine of 90 is just 1, is equal to F2 over sine of 127. Now that means I can capture this and move it up to that side. So when I simplify this, the force of F2 is going to be equal to 20 times 9.8 sine 127 degrees. And when you pop that in the calculator, make sure that it is in the correct mode, which is degrees. It'll give you 117.955. Now, this is a tension in the string, so this is going to be in newtons. Now, our F3 force is going to do the same algebra. We're going to take this across. So that means the force of F3 is going to be equal to 20 times 9.8, bracket, bracket, sine of 143 this time, which is going to give you 156.8 newtons. Now, looking at my book, I think that I have accidentally mixed these two around. So the answer to this should be that, and the answer to this should be that. Okay, but that's how you figure out the tensions in the string. So instead of calling it F2, I'm going to call it T2. Instead of calling it F3, I'm going to call it T3.